What if the Anunnaki didn't simply leave? What if they left us a clock? Not a metaphor for cosmic time, but an actual countdown embedded in clay tablets now scattered across museum basements from London to Baghdad, written in mathematical constants that transcend language, encoded in astronomical calculations so precise that modern computers confirm their accuracy across millennia. What if someone 5,000 years ago was tracking cycles we've only begun to recognize, counting toward an appointed time that the original instruction givers deemed significant enough to warrant the obsessive preservation of numbers, numbers that survived the fall of empires and the burning of libraries and the death of the scribes who copied them without fully understanding what they were transmitting? The tablets still wait in their climate-controlled cases. The calculations still balance. The timer, if it exists, still runs. So before this story pulls you under, subscribe if you're drawn to histories that haven't finished happening yet. Cosmic Countdown. Picture yourself standing in the British Museum's Mesopotamian gallery as closing time approaches, the fluorescent lights dimming to half strength, security guards beginning their rounds through distant corridors, their footsteps echoing on polished floors. Most visitors have already filtered toward the exits, but you linger here before a particular display case on the upper level, drawn by something you cannot quite name. The case contains 2 clay tablets, catalogue numbers K8538 and K14943, each about the size of your palm. Their surfaces entirely covered with the wedge-shaped impressions of cuneiform script pressed into clay by scribes who lived and died nearly 3,000 years ago. These are the Mul.Apin tablets, and according to the small placard beneath them, they represent the most complete astronomical compendium to survive from ancient Mesopotamia, recovered from the ruins of Nineveh, from the legendary library of King Ashurbanipal, who ruled the Assyrian Empire at its height in the 7th century before the Common Era. The tablets themselves date to approximately 1100 BCE. Though the colophons, the ancient equivalent of copyright notices, make clear the scribes were copying from sources far older, sources stretching back into the mists of Sumerian antiquity, perhaps to the very dawn of writing itself. Now lean close to the glass, and you can see the precision of the impressions, each wedge pressed at exactly the right angle and depth, rows upon rows of astronomical data covering every available surface. The conventional interpretation is straightforward enough. These tablets track the heliacal risings of stars, the moments when particular stars first become visible on the eastern horizon just before sunrise. They catalogue the fixed stars into 3 paths across the sky: the path of Anu along the celestial equator, the path of Enlil in the northern sky, the path of Ea in the southern. They record the movements of the wandering stars, what we call planets. Tracking the stately progression of Jupiter and Saturn, the quicker dances of Mars and Venus and Mercury, they predict lunar eclipses using the Saros cycle, that elegant 18-year, 11-day pattern the Babylonians discovered, which allows remarkably accurate prediction of when the moon will darken. All of this makes sense. As practical astronomy, farmers need to know when to plant, priests need to know when to perform rituals, kings need omens to guide their decisions, the rhythms of the sky mapped onto the rhythms of human life. But here is where the tablets become strange. Here is where the comfortable explanation begins to fray at the edges, because embedded within the astronomical tables are calculations that serve no practical purpose whatsoever. cycles within cycles within cycles, extending far beyond any human lifetime, far beyond any dynasty or empire, far beyond the entire span of Mesopotamian civilization itself. The tablets track the movements of Jupiter and Saturn with such precision that they can predict conjunctions, the moments when these two slow giants appear to meet in the sky, not just for the coming years, but for centuries ahead. And they go further still, tracking how these conjunctions slowly precess through the zodiac over periods of roughly 800 years, completing a full circuit through all 12 signs in approximately 2,400 years. They contain calculations for what modern astronomers call the Great Year, the vast cycle of approximately 25,920 years it takes for the spring equinox point to precess completely through the zodiac, returning to the same position against the background stars. Why would Bronze Age astronomers calculate such cycles? What possible use could a civilization that flourished for perhaps 2,000 years have for predictions spanning 12 times that duration? Who were these calculations for? The standard academic answer is religious significance, symbolic importance, the intellectual satisfaction of understanding cosmic order, and perhaps that answer is correct. Perhaps ancient astronomers simply loved the elegance of celestial mechanics and calculated these cycles for the same reason modern mathematicians work on problems with no practical application for the beauty of it. But there is another possibility, one that hovers at the edge of scholarly discussion, rarely spoken aloud in peer-reviewed journals, but persistent nonetheless. What if these calculations were not predictions but countdowns? What if the scribes who pressed these symbols into wet clay were not discovering cycles but preserving them, not creating astronomical knowledge but maintaining it, keeping time for someone else entirely? The British Museum contains over 130,000 cuneiform tablets, most still untranslated. The Emuel-Apin tablets represent only a fragment of the astronomical literature that has survived, and that surviving literature represents only a fraction of what once existed. What if somewhere in that vast archive, in tablets already translated and tablets still waiting, in fragments pieced together and fragments still scattered, there is a date, an end point, an appointed time that the original creators of this astronomical system were counting toward? What if the timer is still running? The Sumerians, who preceded the Babylonians and Assyrians, developed what may be history's most elegant mathematical system, base 60, sexagesimal, a system so useful for astronomical calculation that we still use it today every time we divide an hour into 60 minutes, a minute into 60 seconds, a circle into 360 degrees. The number 60 is remarkable for its divisibility. It can be evenly divided by 2 and 3, and 4 and 5 and 6 and 10 and 12 and 15 and 20 and 30, making it extraordinarily flexible for calculations involving fractions, for astronomy, where you constantly need to divide circles and cycles into smaller units. This is invaluable. But the Sumerians went further. They created units of time that extended the sexagesimal system into cosmic scales. The SOSS equaled 60 years, roughly a human lifetime. The NER equaled 600 years, 10 lifetimes, a span longer than most dynasties. And the SAR equaled 3,600 years, 60 squared, a period longer than the entire documented history of Sumerian civilization. Why create a unit of time that exceeds your entire civilizational lifespan by a factor of nearly 2? What could you possibly measure with it? The Sumerian king list, that strange document we explored in previous journeys, uses these units to describe the reigns of rulers before the flood, antediluvian kings who reigned for 28,800 years, or 36,000 years, or 43,200 years. Numbers that appear impossible if read as individual human lifespans, but become meaningful if understood as epochs, as ages, as units in a larger counting system. The same obsession with vast cycles appears in the astronomical tradition. The Saros cycle of 18 years 11 days predicts eclipses with remarkable accuracy. But the Babylonians knew this was only the beginning. They tracked the exeligmos, 3 Saros cycles, or roughly 54 years, after which eclipses repeat at nearly the same time of day at nearly the same location. They tracked longer cycles still, harmonics of planetary periods interlocking like gears in a cosmic clock. Jupiter takes approximately 12 years to orbit the Sun, Saturn approximately 29 years. Their ratio is close to 5 to 2, meaning they align roughly every 20 years. But these alignments precess slowly through the zodiac, taking approximately 800 years to complete one circuit, and 3 such circuits, approximately 2,400 years, marks 1/4 of the full precessional cycle. The numbers interlock. They build upon each other. They reach toward that ultimate cycle of approximately 25,920 years, the Great Year, the time it takes for the spring equinox to precess through all 12 zodiacal constellations and return to its starting point. Modern astronomy confirms these calculations. The ancient Mesopotamians got it right. But here is the puzzle that keeps certain researchers awake at night. The precession of the equinoxes is a slow drift, approximately 1 degree every 72 years. In a single human lifetime, you would notice a shift of perhaps 1 degree, barely detectable without precise instruments. In 10 lifetimes, you might notice a shift of 10 degrees, still subtle, easily attributed to measurement error or calendar drift. To accurately measure precession, you need either very precise instruments or very long records. The Mesopotamians had neither by conventional archaeological understanding. Their culture flourished for perhaps 3,000 years at most, not nearly long enough to directly observe a full precessional cycle or even a significant fraction of one, yet they knew about it. They calculated it. They incorporated it into their astronomical literature. How did they know? The conventional answer involves brilliant astronomers extrapolating from limited data, projecting observed rates of change into the future. And this answer may be correct. Ancient peoples were not stupid. They were fully capable of mathematical extrapolation. But there is another possibility. What if they did not discover precession through observation? What if they inherited the knowledge from a source that had been observing for far longer? What if the astronomical calculations in the MUL.APIN tablets and other texts preserve knowledge from before, from an earlier civilization that had the time to observe full precessional cycles, or from teachers who came from elsewhere and brought the knowledge with them? The Sumerians themselves claimed their knowledge came from the gods, the Anunnaki, those beings who, according to the texts, descended from heaven to earth in ancient times, lived among humans, taught the arts of civilization, and eventually departed. What if the astronomical system with its cycles extending far beyond any practical purpose, was their gift, their countdown, their timer set before departure. The Sumerian and Babylonian texts are remarkably consistent on one point that modern scholarship tends to treat as purely mythological. The gods left. They did not simply fade from human consciousness as religious ideas evolved. They did not gradually transform into more abstract concepts. According to the texts themselves, the Anunnaki physically departed. They rose to heaven. They withdrew from direct involvement in earthly affairs. The Era Epic, a Babylonian poem from the first millennium BCE that draws on older traditions, describes a period when the great god Marduk temporarily left his temple in Babylon. During his absence, chaos reigned, cosmic order destabilized, lesser gods acted without supervision, causing destruction and suffering. Marduk eventually returned and restored order. But the text makes clear that divine presence is not guaranteed. Gods can leave. Gods do leave. And when they leave, the world suffers. The other texts describe the appointment of human kings to rule in the gods' absence. The Sumerian king list opens with the statement that kingship descended from heaven, as if the institution itself was a gift from divine beings who were establishing a governmental system for their departure. The gods would not always be present to rule directly, so humans would rule in their stead, guided by priests who maintained communication with the departed deities through ritual and divination. The ziggurats, those great stepped pyramids that dominated Mesopotamian cities, were not tombs like Egyptian pyramids. They were temples. Their names reveal their purpose. The ziggurat at Babylon was called Etemenanki, meaning house of the foundation of heaven and earth. The ziggurat at Ur was called Etemenigur, meaning house whose foundation creates terror. These were meeting places, connection points between earth and heaven, structures designed to maintain contact with gods who were no longer physically present. If the gods departed and established institutions to maintain order in their absence, did they also establish a timeline? Did they say when they would return, or when certain events would occur, or what conditions would signal the completion of a cycle? The prophetic literature of Mesopotamia suggests they did. The Enuma Anu Enlil, a vast collection of celestial omens, describes specific astronomical configurations and what they portend for earthly affairs. Certain planetary alignments herald prosperity, others disaster, still others the rise or fall of kings. But scattered throughout this literature are references to appointed times, to fated moments, to events that will occur when the heavens align in specific ways. The word in Akkadian is Adanu, meaning appointed time or fixed date. It appears in contexts suggesting not just prediction, but predetermination, as if certain events were scheduled, written into the fabric of cosmic time, waiting for their moment to unfold. Consider what this would mean if taken seriously, not as mythology, but as a preserved fragment of actual instruction. The gods depart. But before departing, they establish a countdown. They encode it in astronomical cycles that will continue turning, whether humans observe them or not. They build it into the mathematical system itself, into units of time that extend far beyond any single civilization. They create institutions, temples, priesthoods, kingships, to maintain the knowledge through generations of forgetting. And they leave behind tablets, astronomical calculations, prophetic literature that preserve the essential numbers, the key alignments, the markers along the path toward the appointed time. What was that appointed time? When was it scheduled to arrive? For whom was the timer running? The tablets do not say explicitly, or if they do, we have not yet understood them. We can read the cuneiform. We can verify the astronomical calculations. We can trace the mathematical relationships. But the ultimate purpose, the end point of the countdown, remains obscure. Perhaps it was lost when Nineveh burned, when Babylon fell, when the chain of scribal transmission that had preserved this knowledge for millennia finally broke. Perhaps it is still there in tablets not yet translated, in fragments not yet pieced together, in connections not yet made. Or perhaps we are meant to calculate it ourselves, to use the tools they left us, the astronomical cycles, the mathematical constants, the prophetic framework, to determine for ourselves when the timer runs out. What if that moment is approaching? What if we are living in the final counts of a clock that started ticking thousands of years before the first cities rose from the Mesopotamian plain? The question cannot be answered definitively. It can only be asked, and in asking it, we join a chain of questioners that stretches back through millennia. Through Babylonian astronomers gazing at the sky from the summit of Anunnaki, through Assyrian scribes copying tablets in the library of Ashurbanipal, through Sumerian priests who claim their knowledge came from the gods themselves, we stand in that chain tonight. Inheritors of questions we did not create, keepers of a countdown we did not start, wondering when and whether the appointed time will come. Let your breathing slow now. Let the questions settle like sediment drifting to the bottom of a still pool. You have traveled far in a short time, from the British Museum's quiet galleries to the ruins of ancient Babylon, from clay tablets to cosmic cycles, from historical fact to speculative possibility. The boundary between them is not always clear. That is as it should be. The ancient world does not fit neatly into our categories of mythology and history, science and religion, fact and fiction. The Mesopotamians would not have understood these distinctions. For them, the movements of the stars were simultaneously mathematical facts to be calculated and divine messages to be interpreted. The gods were simultaneously cosmic forces and personal beings who walked the earth and left it and might return. We can analyze their texts with modern methods, translate their languages, verify their calculations, but we cannot fully enter their consciousness, cannot know what they meant at the deepest level, only what they said and what they preserved. Close your eyes if you have not already. Feel the weight of your body against whatever surface supports you. The earth beneath that surface has turned through countless cycles since the first cuneiform was pressed into wet clay. Civilizations have risen and fallen, empires have expanded and collapsed, languages have been born and died, and through it all the stars have continued their slow dance across the sky. The same stars the Babylonian astronomers mapped, the same patterns the MUL.APIN tablets describe, the same cycles that continue turning, whether anyone watches them or not. If there is a timer encoded in those ancient calculations, it runs independently of human awareness. It does not require our belief or understanding. It simply is, like the stars themselves, like the slow precession of the equinoxes, like time itself moving forward, regardless of who observes it or what they think it means. You are safe in this moment, exploring ideas that may or may not be true. Some of what we discuss tonight has scholarly support, specific tablets, translated texts, verified calculations, Some ventures into interpretation that mainstream academia would reject. Both are part of the journey. Both deserve consideration, not necessarily belief, but consideration. The willingness to ask what if before demanding proof. The openness to possibility that makes exploration worthwhile. If you have already begun to drift into sleep, that is perfect. These ideas do not require waking attention. They can settle into the deeper layers of consciousness, where connections form without effort, where patterns emerge without analysis, where the ancient and the modern meet in dreams. The story continues. The countdown runs, and you can rest within it, carried forward by currents older than any civilization we know. Ancient Timer. In 1976, a book appeared that would ignite decades of controversy and fascination in equal measure. A book that proposed something so audacious that mainstream scholarship dismissed it almost immediately, while millions of readers around the world found themselves unable to look away. Zecharia Sitchin, a self-taught scholar of ancient languages who had spent years poring over Sumerian and Akkadian texts, published The 12th Planet, the first volume in what would become a series of books, arguing that the Anunnaki were not mythological figures at all, but flesh and blood beings from another world. Visitors from a planet called Nibiru that follows a highly elliptical orbit, bringing it through our inner solar system once every 3,600 years. According to Sitchin, this 3,600-year period corresponded exactly to the Sumerian SAR, that great unit of time we encountered earlier, and it represented not a mathematical abstraction, but an actual orbital cycle, the year of the gods as measured by celestial mechanics rather than earthly seasons. The Anunnaki, in this interpretation, did not choose when to come and go from Earth any more than we choose when summer arrives or winter retreats. They were bound by the same gravitational laws that govern all planetary motion, arriving when Nibiru swept close to the sun, and departing when its elongated path carried it back out into the frozen reaches beyond the known planets. A journey that would take them so far from solar warmth that they would need to remain on their homeworld during the long, dark passage, returning to Earth only when orbital mechanics brought them close enough to make the crossing feasible. Sitchin built his argument on several pillars of evidence that he claimed mainstream Assyriology had either misunderstood or deliberately ignored, and chief among these was a cylinder seal, now housed in the Vorderasiatisches Museum in Berlin, catalogued as VA243, a small, carved cylinder that, when rolled across wet clay, produces an image showing two seated figures flanked by what appears to be a star surrounded by 11 smaller bodies. Sitchin interpreted this image as a map of our solar system, showing the Sun at center surrounded by all 9 planets, known to modern astronomy, plus the Moon, plus Nibiru itself, a 12th celestial body that ancient astronomers recorded, but modern science has either lost track of or refuses to acknowledge. He pointed to the precision of Sumerian astronomical knowledge as evidence that they must have had teachers who understood our solar system far more completely than any Bronze Age civilization should have been capable of understanding it on their own. Teachers who knew about the outer planets, who tracked orbital periods with remarkable accuracy, who calculated celestial mechanics that would not be matched by Western science until the invention of the telescope thousands of years later. The term Nibiru itself appears in genuine Mesopotamian astronomical texts, Sitchin noted, where it is described as a celestial body that crosses or a point of crossing. Language that he interpreted as describing a planet on an orbit so eccentric that it literally crosses through the orbital paths of the inner planets before retreating back into the outer darkness. The texts speak of Nibiru appearing at intervals, of its approach being a time of significance and often danger, of the gods associated with it exercising power over earthly affairs when it draws near. Sitchin connected these astronomical references to the mythological accounts of the Anunnaki descending from heaven, establishing their cities on Earth, creating humanity to serve as workers, and eventually departing with promises or warnings about their eventual return. In this reading, the entire corpus of Sumerian mythology becomes a historical record, garbled by time and oral transmission, but preserving at its core an accurate account of extraterrestrial contact and colonization. A record that the priests and scribes of ancient Mesopotamia faithfully copied and recopied across millennia without fully understanding what they were preserving. Just as a monk in a medieval monastery might copy Greek philosophical texts in a language he cannot read, trusting that the knowledge within is valuable even if its meaning has become opaque. The appeal of Sitchin's hypothesis is undeniable. It offers a grand unified theory that explains not only the origin of Sumerian civilization, but also the global pattern of flood myths, the sudden emergence of agriculture and writing, the sophisticated astronomical knowledge of ancient peoples, and the persistent human sense that the gods are somehow absent, withdrawn, departed to a place beyond easy reach, but destined to return. It transforms confusing mythological imagery into straightforward historical narrative. It gives meaning to numbers and cycles that otherwise seem arbitrary or symbolic. And it promises that the great questions, where did we come from? Why are we here? Are we alone? Might have answers encoded in the very oldest texts humanity possesses, waiting for someone with the right keys to unlock them. But we must also honestly examine what mainstream scholarship says about these claims. Because intellectual honesty requires that we hold even the most fascinating theories up to scrutiny, and the scholarly critique of Sitchin's work has been extensive and often devastating. Professional Assyriologists, those who have spent their careers learning the intricacies of cuneiform script and the grammar of Sumerian and Akkadian, have consistently found that Sitchin's translations contain errors, some of them significant enough to undermine his central arguments. The cylinder seal VA243, that cornerstone of the Nibiru hypothesis, has been analyzed by experts who point out that the central figure is almost certainly a star symbol, not the sun, and that the surrounding bodies show no evidence of being planets in any ordered arrangement. The image more likely depicts a divine figure surrounded by stellar symbols, a common motif in Mesopotamian art that carries religious rather than astronomical significance. The number of bodies shown varies depending on which seals you examine, and the specific count of 11 or 12 only emerges when you include certain background elements while excluding others. A selective reading that critics argue reveals more about the interpreter's desires than the artist's intentions. The term Nibiru, when examined in its full textual context across all the tablets where it appears, seems most often to refer to Jupiter, or to a point in the sky where the sun crosses the celestial equator, the spring equinox point that was of enormous importance to Mesopotamian astronomers for calendrical purposes. The crossing that the name implies may refer not to a planetary orbit, but to the Sun's apparent path across this astronomical boundary, an event that occurred every year and marked the beginning of the new year in the Babylonian calendar. As for the SAR and its 3,600-year period, critics point out that this number emerges naturally from the sexagesimal number system as simply 60 squared, a mathematically elegant figure that would appeal to Mesopotamian arithmeticians regardless of any astronomical correspondence. We use similarly round numbers constantly, speaking of centuries and millennia, without implying that 100 or 1,000 years corresponds to any celestial cycle. The SAR may be nothing more than a convenient large number in a culture that thought in base 60, are chosen for its mathematical properties rather than its astronomical significance. And yet, even as we acknowledge these criticisms, even as we accept that Sitchin's specific claims about Nibiru and its 3,600-year orbit lack support from mainstream scholarship, certain questions remain. The Sumerians did possess astronomical knowledge of remarkable sophistication. They did track planetary periods with precision that seems almost anachronistic. They did embed these calculations in texts that extend far beyond practical necessity into timescales no contemporary human would ever witness. They did speak of the gods departing and returning, of appointed times and cosmic cycles. If Sitchin was wrong about the specifics, might he have been pointing towards something real that we have simply misidentified? Or perhaps the timer is not orbital but precessional. Perhaps the countdown is not tied to a hypothetical planet, but to something we can actually measure, something the Mesopotamians demonstrably tracked and understood, something that provides a far more solid foundation for the concept of an ancient countdown than any speculation about trans-Neptunian worlds. Let us turn now to what the Sumerians and their Babylonian successors certainly knew: the precession of the equinoxes. If you watch the night sky carefully over the course of a year, you will notice that the sun appears to move through a belt of constellations, the zodiac, rising each morning against a slowly shifting stellar background. Ancient astronomers tracked this movement meticulously because it governed their calendar, their agricultural cycle, their religious festivals. But there is a slower movement hidden within this annual cycle, so slow that it takes approximately 72 years to shift the position of the spring equinox by a single degree against the background stars. So slow that no single human lifetime would ever witness more than a fraction of its progression. This is the precession of the equinoxes, caused by a wobble in Earth's rotational axis, a wobble that takes approximately 25,920 years to complete one full cycle. The Greek astronomer Hipparchus is traditionally credited with discovering precession around 127 BCE. But there is growing evidence that earlier civilizations were aware of this phenomenon, even if they described it in different terms and embedded their knowledge in mythology rather than mathematical treatises. The Mesopotamian texts speak of a great year, a cosmic cycle far longer than any human life, during which the heavens slowly shift their positions before eventually returning to their original configuration. The zodiac itself, divided into 12 houses of approximately 30 degrees each, may represent an attempt to track this precessional movement by noting which constellation the sun rises in at the spring equinox. Each zodiacal age lasts approximately 2,160 years, the time it takes for precession to shift the equinox point through 30 degrees of celestial longitude. The Sumerians flourished during the transition from the age of Taurus to the age of Aries, and their mythology reflects this shift in fascinating ways. The bull imagery, so prominent in early Mesopotamian religion, the great bulls that guarded temple gates, the bull of heaven that appears in the Epic of Gilgamesh. These may represent the zodiacal age that was ending as Sumerian civilization reached its peak. The ram imagery that becomes increasingly prominent in later periods, particularly in Babylonian and then Persian religion, may reflect the New Age dawning. And the fish symbolism that pervades the era of early Christianity, the ichthys sign, Jesus as fisher of men, the feeding of the multitudes with fish. This may reflect awareness that yet another age was beginning as the equinox point moved into Pisces. We are now, according to most calculations, in the final centuries of the Piscean age, transitioning toward Aquarius. The exact dates are disputed because the boundaries of constellations are not precisely defined, but the transition is occurring roughly now in our era in the generations currently alive on Earth. The concept of the Age of Aquarius that entered popular culture through the 1960s was not invented by hippies or astrologers, but represents an authentic astronomical phenomenon that ancient cultures tracked and invested with enormous significance. If the Anunnaki understood precession, and the evidence suggests that Mesopotamian astronomers did track this phenomenon, even if they conceptualized it differently than we do, they could have established a countdown based on precessional ages rather than planetary orbits. The timer would not depend on a hypothetical planet that may not exist. It would be tied to measurable, verifiable astronomical phenomena that any sufficiently advanced observer could calculate and confirm. We will return when the sun rises in constellation X at the spring equinox, when the great wheel has turned through Y number of ages, when the celestial markers align in configuration Z. This would be a timer that transcends culture and language because it is written in the heavens themselves. Any civilization with sophisticated astronomical knowledge would be able to read it, regardless of what languages they spoke or what names they gave the stars. The countdown would be built into the cosmos itself, patient, precise, impossible to tamper with or destroy, because you cannot destroy the precession of Earth's axis. You can only wait for it to complete its appointed cycles. The Sumerian astronomical tablets, with their calculations extending thousands of years into the future, might represent not idle mathematical speculation, but careful tracking of exactly this kind of timer. A countdown established by the departing gods, preserved by priests who might not have fully understood what they were preserving, copied by scribes across millennia who trusted that the numbers were important, even if their ultimate significance had been lost. And if this interpretation holds any weight, then the current precessional transition, the shift from Pisces to Aquarius occurring in our era, might be exactly the kind of marker the ancient timer was counting toward. Not an orbital return of a hypothetical planet, but a celestial configuration that the original designers of the countdown deemed significant. An appointed time that the heavens themselves would announce to anyone with eyes to see and the astronomical knowledge to interpret what they were seeing. But perhaps the timer was not counting toward a return at all. Perhaps it was counting towards something else entirely, something that the Anunnaki, or whoever established the countdown, understood to be a recurring feature of existence on Earth, something that had happened before and would happen again, something that required warning and preparation rather than welcome and celebration. Let us examine the evidence for cyclical catastrophism, for reset events that punctuate human history at semi-regular intervals, and consider whether the ancient timer might have been pointing not toward the god's return, but toward the next great disruption. The geological and archaeological record shows a disturbing pattern of catastrophic events occurring throughout the span of human prehistory and history, events that collapsed civilizations, caused mass extinctions, and fundamentally reset the trajectory of human development. Approximately 12,800 years ago, at the end of the last ice age, something catastrophic happened. Ice cores from Greenland show a sudden dramatic cooling event that reversed the warming trend and plunged the northern hemisphere back into near-glacial conditions for over 1,000 years. This period, known as the Younger Dryas, coincides with mass extinctions of megafauna across North America, including mammoths, mastodons, giant ground sloths, saber-toothed cats, and dozens of other species that had survived previous climate fluctuations, but vanished suddenly and completely at this boundary. The cause remains debated, but growing evidence supports the Younger Dryas impact hypothesis, and is suggesting that Earth was struck by fragments of a disintegrating comet that caused widespread fires, deposited anomalous materials in sediment layers worldwide, and triggered the climate disruption that followed. Platinum spikes, nanodiamonds, and shocked quartz have been found in the boundary layer at sites across North America, Europe, and as far away as South Africa, markers that suggest extraterrestrial impact events. If humans had developed any sophisticated cultures by this time, if there were proto-civilizations beginning to form along Ice Age coastlines, they would have been devastated utterly. Their settlements flooded as sea levels rose dramatically in the aftermath. Their populations crashed, their knowledge scattered and largely lost. The survivors would have passed down memories of the destruction, memories that became the flood myths found in every culture worldwide. Stories of a time when the world ended and only a handful survived to begin again. Approximately 8,200 years ago, another abrupt climate event disrupted developing human civilizations. The 8.2 kiloyear event shows in ice cores and sediment records as a sudden cooling period lasting several centuries, possibly triggered by the catastrophic drainage of glacial lakes in North America that disrupted Atlantic Ocean circulation. This event correlates with cultural disruptions across the early agricultural Near East, the abandonment of settlements, the collapse of early farming communities that had to relocate and re-establish themselves in the face of suddenly hostile climate conditions. Approximately 4,200 years ago, yet another catastrophic event struck. This one showing clearly in the archaeological record as the collapse of major Bronze Age civilizations across a wide geographic range. The Akkadian Empire in Mesopotamia collapsed. The Old Kingdom of Egypt ended in chaos and fragmentation. The Indus Valley civilization entered terminal decline. The early Bronze Age cultures of the Aegean and Anatolia collapsed simultaneously. The 4.2 kiloyear event appears to have been primarily a mega drought, centuries of reduced rainfall that made agricultural civilizations dependent on marginal lands simply unsustainable, triggering famines, migrations, wars, and societal collapse across an enormous geographic range. And approximately 3,200 years ago, the Bronze Age collapse brought down the great palace civilizations of the Eastern Mediterranean in a catastrophe so complete that literacy was lost in Greece for centuries, and entire peoples vanished from the historical record. The sea peoples who ravaged the coasts, the famines that emptied cities, the earthquakes and fires that appear in the destruction layers, these combined to end an entire era of human civilization and usher in the Dark Age from which classical Greece would eventually emerge. The pattern suggests catastrophic events occurring at roughly 2,000 to 4,000 year intervals, though the intervals are not perfectly regular and the causes appear to vary. Climate disruption, cosmic impact, drought, volcanic eruption, plague, societal collapse cascading through interconnected trade networks. All of these appear in the record at different times and in different combinations. But the pattern of periodic reset events, of civilizations rising to heights and then crashing down to be replaced by survivors building anew from the ruins, this pattern is undeniable. And if ancient astronomers were tracking cycles that correlated with these catastrophic events, if they had discovered through observation and record-keeping that certain celestial configurations preceded certain types of disaster, they might have encoded this knowledge in countdown form. Not, "We will return when the timer reaches 0, but be warned, when the timer reaches 0, destruction follows." The flood myths might preserve not just memory of past catastrophes, but warning of future ones. The astronomical tablets might encode not return dates, but danger dates, markers of when the celestial conditions that preceded previous disasters would recur. The timer might be not a promise, but a warning, encoded in the only language that would survive the very catastrophes it predicted, the language of mathematics and astronomy, written in numbers that would mean the same thing to any sufficiently advanced observer, regardless of what tongue they spoke or what culture they inhabited. If this interpretation holds weight, then the question becomes not when are the Anunnaki coming back, but what happens when the timer reaches its next significant marker? What are the celestial conditions that preceded past catastrophes? Have we identified them correctly? Are they approaching again? And perhaps most importantly, what would preparation look like? How do you prepare for a civilization-ending event? What do you preserve? What do you protect? What do you encode so that the survivors can rebuild more quickly, can avoid the mistakes of the previous cycle, can perhaps eventually break the cycle altogether and achieve something that no previous civilization managed to achieve? Let your breathing slow now. These are vast ideas, stretching across millennia like the orbits we have been tracing, like the processional ages wheeling slowly through their appointed rounds. You do not need to hold all of them at once. You do not need to resolve the contradictions or choose between interpretations. Let them drift like stars moving across the dome of night, each one a point of light in a pattern larger than any single mind can fully grasp. A pattern that might be meaningful or might be merely beautiful, or might somehow be both simultaneously. The earth beneath you has turned through countless such cycles. Ice ages have come and gone. Civilizations have risen and fallen like tides. Species have flourished and vanished, while the continents themselves drifted slowly across the face of the planet. And yet, here you are, conscious, wondering, part of the great chain of being that stretches back through all those cycles to whoever first looked up at the stars and began to count. The Sumerians counted, the Babylonians counted, the Egyptians and the Mayans and the Hindus counted. They tracked cycles longer than any individual life could witness, passed their calculations forward through generations, preserved numbers whose significance they might not have fully understood but trusted were important enough to preserve. And now we count. We track precession with precision they could only dream of. We date ice cores and sediment layers and know exactly when past catastrophes occurred. We map the heavens with telescopes and satellites, charting every object in our solar system, searching for any planet or comet or asteroid that might threaten our world. We are the inheritors of all that counting, all that watching, all that patient accumulation of astronomical knowledge across millennia. Whether the timer is real or imagined, whether the countdown marks a return or a catastrophe or nothing at all, we are here in this moment, connected to all those watchers who came before, part of the same great project of understanding where we are in cosmic time and what that position might mean. Rest now in that connection. Let the numbers drift away. Let the theories fade into the background hum of possibility. The timer, if it exists, will still be ticking tomorrow. The stars will still be moving through their appointed courses. The procession will continue its slow wheel through the ages, regardless of whether you are awake to watch it. For now, simply be here in this moment, breathing, resting, part of the pattern, even if the pattern remains mysterious. The cycle continues whether we understand it or not. And perhaps that is the deepest truth the ancients were trying to preserve. Not a specific date or a specific event, but the simple awareness that cycles exist, that time moves in patterns larger than individual lives, that we are part of something vast and ancient and ongoing. That awareness itself is valuable, regardless of whether any specific countdown reaches any specific conclusion. It connects us to the deep past and extends us toward the far future. It makes us citizens of cosmic time rather than prisoners of the immediate moment. And in that awareness, in that connection, there is something like peace, something like rest, something like the quiet that comes when you stop fighting the current and simply float, trusting that the river knows where it is going, even if you cannot see around the next bend. Celestial Countdown. Let us return now to the MUL.APIN tablets with fresh understanding, with the accumulated weight of everything we have explored together, because these clay rectangles sitting in their museum cases contain something that becomes stranger the closer you examine it, is something that transforms from practical astronomy into something else entirely when you begin to trace the full scope of what the ancient scribes were calculating. The tablets track Saturn with remarkable precision, noting that the ringed planet completes its circuit through the zodiac in approximately 29.5 years. And they track Jupiter with equal care, recording its cycle of nearly 12 years. And these observations alone would be impressive enough for a civilization working without telescopes, using only naked eye observation and careful record-keeping across generations. But the tablets go further, much further, into territory that raises questions scholars have never adequately answered. They calculate what happens when these two great planets, the slowest moving visible objects in the night sky, they come together in conjunction, an event that occurs approximately every 20 years when Jupiter catches up to Saturn in their endless race around the Sun. The Babylonian astronomers tracked these conjunctions with obsessive precision, noting not just when they occurred, but where in the zodiac they appeared, and they discovered something remarkable. Something that suggests they were watching for patterns far longer than any individual lifetime could encompass. Each successive conjunction of Jupiter and Saturn occurs approximately 1/3 of the way around the zodiac from the previous one, roughly 120 degrees ahead, which means that after 3 conjunctions, about 60 years, the alignment returns to approximately the same region of the sky, but not exactly the same position, slightly shifted, slowly rotating through the heavens over centuries. The tablets track this shift, calculate its rate, project it forward, and arrive at a stunning conclusion that the complete cycle, the time it takes for the great conjunctions to rotate fully through the zodiac and return to their original position, spans approximately 800 years. This is the Trigon cycle, and the Babylonians tracked it across multiple complete rotations, calculating forward and backward through time periods that dwarf the lifespan of their civilization. But even this 800-year cycle was not the limit of their calculations. They computed multiples, noting that 3 complete Trigon cycles, approximately 2,400 years, brought certain planetary configurations into alignment with their starting positions. And they tracked longer harmonics still, building mathematical frameworks that extended to periods of thousands upon thousands of years. The question that emerges from these calculations is devastatingly simple. Why would anyone do this? The practical applications of astronomy in ancient Mesopotamia are well documented and entirely sensible. You need to know when to plant crops, so you track the seasons through stellar observations. You need to predict floods, so you correlate river levels with celestial events. You need to maintain religious calendars, so you track lunar cycles for festival timing. You need to establish royal legitimacy, so you read omens in planetary positions. All of this explains why the Babylonians would track celestial events spanning months or years, or perhaps even decades. But none of it explains why they would calculate planetary positions thousands of years into the future, long after every person then living would have died, long after the empire itself would have crumbled to dust, long after the very language they wrote in would become extinct and need to be rediscovered by archaeologists in the 19th century. The calculations in the MUL.APIN tablets extend to the precessional cycle itself, that vast slow wobble of the Earth's axis that takes approximately 25,920 years to complete, shifting which stars rise with the Sun at the equinoxes, slowly rotating the entire celestial coordinate system against the background of fixed stars. Modern astronomers only confirmed the precise length of this cycle in recent centuries, using advanced mathematics and careful observation. The Babylonians, working with reed styluses pressed into wet clay, arrived at figures that match modern calculations with disturbing accuracy. They knew the precessional period. They tracked it. They calculated where the equinox point would be thousands of years before and thousands of years after their own era. The standard scholarly explanation for this mathematical sophistication is that the Babylonians loved astronomy, that they developed increasingly refined techniques over centuries, that their scribal traditions valued precision, and their priestly classes had the leisure time to pursue such calculations. This explanation is not wrong, but it feels incomplete, like describing why a master clockmaker builds an elaborate timepiece by saying he enjoyed working with gears. The deeper question remains: what were they timing? What event, or alignment, or cosmic configuration was significant enough to warrant tracking cycles that would complete long after everyone who participated in the calculations had returned to dust? The tablets themselves offer hints but not answers, calculating positions but not explaining purposes, preserving the mechanism of the countdown without preserving the appointment it counted toward. Now, imagine yourself standing at the base of a ziggurat in ancient Babylon, one of those massive stepped pyramids that dominated Mesopotamian cities, like mountains of human construction, their terraces rising toward the heavens in deliberate geometric progression. The most famous of these, the ziggurat of Marduk in Babylon, rose over 300 feet into the air, visible for miles across the flat alluvial plain. Its 7 stages painted in different colors according to some accounts. Its summit crowned with a temple where the priests maintained their nightly watch of the heavens. Modern archaeology has recovered the foundation plans of many ziggurats, measured their orientations, analyzed their proportions, and discovered something that transforms these structures from mere temples into something more complex, more deliberate, more time-bound than simple religious architecture. The ziggurats are oriented to the cardinal directions with precision that speaks of careful astronomical observation over extended periods. They do not merely face north in a general sense, but align to true north with accuracy that required tracking star positions across seasons, possibly across years, to determine the exact axis around which the heavens appear to rotate. This orientation was not accidental or approximate. It was deliberate and precise, encoding astronomical knowledge into the very foundations of the structures. But here is what makes the ziggurats stranger still. Archaeological evidence suggests that some temples in Mesopotamia were periodically rebuilt, not because they had collapsed or fallen into disrepair, but because their orientations no longer matched the current celestial configuration. Precession shifts the heavens by approximately 1 degree every 72 years, which means that a structure precisely aligned to a particular star or constellation will slowly drift out of alignment over centuries, the star rising slightly east or west of where it rose when the alignment was first established. The Mesopotamians knew this. They tracked it. And at least some evidence suggests they responded to it, reconstructing sacred architecture to maintain precise celestial correspondence across the ages. This practice transforms the ziggurats from static monuments into dynamic instruments, cosmic clocks that required periodic adjustment as the heavens themselves shifted, buildings that embodied not just the celestial configuration of a single moment, but the ongoing relationship between earth and sky across precessional time. The question becomes even more intriguing when we look beyond Mesopotamia and discover the same principle encoded in sacred architecture across the ancient world. The Great Pyramid of Giza aligns to true north with accuracy of approximately 3/60ths of a degree, an orientation that modern surveyors struggle to match even with advanced instruments. Its internal shafts point towards specific stars as they appeared in Egyptian skies around 2500 BCE, including the stars of Orion's belt, which the Egyptians associated with Osiris, and the star Thuban in the constellation Draco, which served as the pole star during that era. These alignments are not disputed by mainstream Egyptology, though interpretations of their purpose vary widely. What is remarkable is that whoever designed the pyramid knew exactly where these stars would appear at the time of construction and encoded that knowledge into stone geometry that would preserve the information indefinitely. Stonehenge on the Salisbury Plain of England aligns to the midsummer sunrise and midwinter sunset with precision that has been verified through modern astronomical calculation. But some researchers argue that the monument encodes precessional information as well, that its geometry references not just the annual solar cycle, but the much longer cycle of axial precession, creating a marker that would allow future generations to determine how much time had passed since the monument's construction by comparing current stellar positions to those implied by its alignments. Angkor Wat in Cambodia presents perhaps the most striking case. The temple complex aligns to the constellation Draco as it appeared approximately 10,000 years ago, not as it appeared during the conventionally accepted construction date of the 12th century CE. This discrepancy has been explained in various ways by various researchers. Perhaps the builders were deliberately encoding ancient astronomical knowledge. Perhaps they inherited alignments from an earlier structure on the same site. Perhaps the analysis is flawed. But the possibility remains that sacred architecture worldwide was designed to function across vast timescales, preserving astronomical information that would remain readable long after the languages of the builders had been forgotten, long after their civilizations had collapsed, long after everything but the stones themselves had returned to Earth. If you wanted to preserve a countdown that would survive anything, survive flood and fire and conquest and the simple erosion of human memory across millennia, you would not write it on paper that decays, or clay that can be smashed, or even metal that can be melted down and recast. You would build it into the landscape itself, into massive stone structures aligned to celestial reference points that do not change on human timescales, creating markers that any astronomically sophisticated civilization could read regardless of what languages they spoke or what cultural frameworks they inherited. The structures would function as clocks, their alignments indicating when they were built, their geometry encoding astronomical relationships that would allow future observers to calculate how much time had passed since their construction. And if the alignments were tied not just to the moment of building, but to specific future configurations, the structures would function as more than clocks. They would function as countdowns, pointing toward appointed times when certain celestial conditions would recur. The times that the original builders clearly considered significant enough to warrant the enormous investment of labor and resources required to construct monuments on this scale. We cannot prove that this was the purpose of the ziggurats or the pyramids or Stonehenge or Angkor Wat. We can only note that the structures exist, that they encode astronomical information with remarkable precision, that they have survived thousands of years when virtually everything else from their eras has been lost, and that they continue to point toward the heavens in silent testimony to whatever knowledge their builders considered worth preserving for eternity. The numbers themselves may be the most durable encoding of all, more lasting than clay or stone, are preserved in mathematical relationships that transcend language and culture and the rise and fall of civilizations. Consider the base 60 system that the Sumerians developed and that we still use today every time we check the clock or measure an angle or navigate by compass heading. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These are not arbitrary conventions. They derive from Mesopotamia, from decisions made over 4,000 years ago by people who chose 60 as their mathematical foundation and embedded that choice so deeply into human culture that we cannot imagine measuring time or space any other way. But why 60? The standard explanation is that 60 is highly divisible, breaking evenly into halves, thirds, quarters, fifths, sixths, tenths, twelfths, 15ths, 20ths, and 30ths, making it convenient for practical calculations. This is true as far as it goes. But there may be another reason, a reason connected to the astronomical cycles that the Mesopotamians tracked with such obsessive precision. 60 is approximately the number of years it takes for Saturn to complete 2 full orbits of the Sun, returning to approximately the same position in the zodiac. 60 is approximately the number of years required for Jupiter and Saturn to complete 3 great conjunctions and return to the same triangular configuration. 60 is approximately the number of years in one major generation cycle of human society. 3 generations of 20 years each, long enough for grandfather, father, and son to each reach adulthood. The number carries astronomical weight, and when you square 60, you get 3,600, the SAR unit that appears throughout Mesopotamian chronology. The unit used to measure the impossibly long reigns of the antediluvian kings. The unit that some researchers connect to the orbital period of the hypothetical planet Nibiru in Zecharia Sitchin's controversial interpretation. Whether or not Sitchin was correct about Nibiru, the SAR remains significant, a mathematical constant that bridges human timekeeping and cosmic cycles, embedded in the very foundation of how we measure time and space. Now consider the number 432,000, a number that appears with troubling frequency across cultures that supposedly had no contact with each other. In Hindu chronology, the Kali Yuga, the current age of darkness, lasts exactly 432,000 years. This is not an approximation or a round number. It is precise, and it serves as the base unit for all the larger yugas. The Treta Yuga is 2 times 432,000. The Dwapara Yuga is 3 times 432,000. The Satya Yuga is 4 times 432,000. The Mahayuga, that contains all 4 ages, is 10 times 432,000. The precision is striking, and the number itself is not arbitrary. 432,000 is exactly 120 times 3,600, connecting the Hindu system to the Mesopotamian SAR through simple multiplication. It is also exactly 1/6 of the precessional cycle of approximately 25,920 years multiplied by 100. The mathematical relationships interlock, but it goes further. The number 432,000 appears in Norse mythology, where the warriors in Valhalla number 432,800 from each of the 540 doors. It appears in analysis of the dimensions of the Great Pyramid, where some researchers argue that various measurements encode 432,000 or its derivatives. It appears in the traditional count of years assigned to the Sumerian antediluvian kings in certain versions of the king list. It appears in the traditional count of syllables in the Rig Veda according to some analysis. It appears, in short, in places where it has no obvious reason to appear unless it was deliberately encoded. Unless someone at some point embedded this number into cultural traditions as a marker, a reference point, a key to understanding larger temporal frameworks. The number 72 is equally significant. 72 years is the time required for the precession of the equinoxes to shift by 1 degree, a rate of approximately 50 arc-seconds per year. This number also appears across cultures with remarkable frequency. There were 72 conspirators in the Egyptian myth of Osiris's murder. Jesus sent 72 disciples according to some gospel manuscripts. The Kabbalah describes 72 names of God. Chinese tradition recognizes 72 land of happiness. The list continues, each instance perhaps coincidental, perhaps deliberate, but collectively suggesting that someone at some point understood the processional constant and embedded it into religious and mythological frameworks worldwide. And then there is the processional cycle itself, that vast slow wobble spanning approximately 25,920 years, dividing neatly into 12 ages of approximately 2,160 years each, the ages of the zodiac through which the vernal equinox slowly retreats. The Sumerians knew this number, calculated it, tracked it. The Egyptians appear to have known it. The Mayans developed calendars that some researchers argue encoded processional awareness. The Hindus incorporated it into their yuga system. Either all of these cultures independently discovered the same astronomical phenomenon and independently calculated its period with similar accuracy, or the knowledge came from a common source and diffused across the ancient world. Or perhaps, most disturbingly, the knowledge was deliberately planted, encoded in mathematical constants that would survive any particular language or culture, waiting to be recognized by future civilizations sophisticated enough to understand what they were looking at. If you wanted to embed a timer in human consciousness that would persist across millennia, surviving the death of languages and the fall of empires, you would not write it in words that can be forgotten or symbols that can be misinterpreted. You would write it in numbers, in mathematical constants derived from the cosmos itself, in ratios that any astronomically aware civilization would recognize because they describe observable reality. The timer would not depend on translation or interpretation. It would simply be there, waiting, the same numbers appearing again and again across cultures and centuries until someone finally recognized the pattern and began to ask what appointment all those ancient timekeepers were marking. The prophetic traditions of ancient Mesopotamia add another dimension to this pattern, transforming astronomical calculations into predictions of earthly events, connecting celestial configurations to the fate of kings and nations, and perhaps to larger cosmic cycles that transcend individual civilizations entirely. The Enuma Anu Enlil is a collection of approximately 7,000 celestial omens compiled by Babylonian scholars, the most comprehensive attempt in ancient history to systematize the relationship between heavenly signs and earthly consequences. When this star appears, the king will die. When these planets conjoin, war will come. When the moon shows this color at this phase, famine follows. The omens cover every conceivable celestial phenomenon, from the positions of planets to the colors of halos around the moon to the appearance of clouds at sunset. Each phenomenon linked to specific predicted outcomes, creating an elaborate system for reading the future in the sky. Modern scholars typically dismiss this literature as superstition, the primitive attempt of pre-scientific cultures to find meaning in random natural phenomena. And perhaps that dismissal is correct. Perhaps the omens reflect nothing more than human pattern-seeking applied to celestial events that have no actual connection to earthly affairs. But consider the sophistication of the astronomical observations underlying these predictions. The Babylonians did not simply note that certain events seemed to correlate. They tracked planetary positions with precision that modern astronomers respect. They calculated eclipse cycles accurate enough to predict lunar eclipses centuries in advance. They developed mathematical models of planetary motion that Greek astronomers later adopted and refined. These were not ignorant people projecting fantasy onto the heavens. They were careful observers who believed, for reasons we do not fully understand, that the cosmos communicated information about the future through celestial configurations, and they devoted enormous resources to recording and systematizing that communication. The concept of Shimtu, often translated as fate or destiny, pervades Mesopotamian thought, representing the predetermined course of events established by the gods and written in the heavens for those with the knowledge to read it. A Shimtu was not vague or abstract. It was specific, connected to particular dates and configurations, determinable through proper observation and calculation. The scribes who compiled the omen literature believed they were decoding a message that had been encoded in the structure of the cosmos itself. Reading a text written in planetary movements and stellar risings, a text that predicted not just individual events, but the larger rhythm of ages. And here is where the prophetic traditions connect most directly to the concept of an embedded timer. Certain omens reference not just immediate events, but recurring patterns, phenomena that repeat on cycles spanning centuries or millennia, then configurations that the gods themselves were said to have established at the beginning of time, and that would recur at appointed intervals until the end of the current age. The concept of Adanu, the appointed time, appears throughout Mesopotamian literature, representing moments of cosmic significance when fate pivots, when ages end and begin, when the gods themselves intervene in human affairs. These appointed times were not arbitrary. They were determined by celestial configurations calculated in advance, predicted through the same mathematical techniques that tracked planetary periods and precessional ages. The prophetic traditions thus represent an interpretation layer applied to the astronomical calculations, transforming pure mathematics into meaning. Now converting the abstract countdown encoded in celestial cycles into specific predictions about what would happen when those cycles completed. The texts speak of Nibiru crossing, an event that some researchers connect to the return of a hypothetical planet, but that might represent any number of astronomical configurations. Perhaps the passage of the equinox point across certain celestial boundaries. Perhaps the alignment of certain planets in certain houses. Perhaps configurations we no longer recognize because the interpretive key has been lost. The texts speak of Marduk's return, when the great god of Babylon would restore the city to its former glory and establish justice throughout the land, an event tied in prophetic literature to specific celestial configurations that the priests calculated and anticipated. The texts speak of the end of the current age and the beginning of the next, transitions marked by cosmic signs that the astronomers tracked with the same precision they applied to eclipse predictions and planetary period calculations. Whether these prophecies reflect genuine knowledge of cyclical cosmic events, or hopeful projection, or political propaganda dressed in celestial language, they demonstrate that the Mesopotamians did not merely calculate astronomical cycles as an intellectual exercise. They believed those cycles meant something, pointed toward something, counted down toward appointed times when significant events would occur. The timer was not just mathematical. It was prophetic, eschatological, embedded not only in numbers, but in expectations, in predictions, is in the accumulated weight of priestly observation across centuries. And the most troubling aspect of these prophetic traditions is that they have not been definitively proven wrong. The appointed times may or may not have arrived. The predicted events may or may not have occurred. We interpret the prophecies through the lens of our own assumptions, seeing metaphor where the original scribes may have intended literal prediction, dismissing as superstition what may have been careful observation of patterns we no longer recognize. The timer continues to run. The celestial configurations continue to shift. And somewhere in museum basements and academic archives, the tablets wait with their calculations and predictions, their omens and their appointed times, their encoded countdown toward whatever the ancient astronomers believed was coming when the stars aligned as they had predicted. Global countdown. Now we must travel east, far from the dust of Mesopotamia, across mountains and deserts and the vast expanse of the Indian subcontinent, to examine a system of cosmic time that has haunted scholars of comparative mythology for over a century, a system so mathematically precise, so structurally parallel to what we have found in the Sumerian tablets, that coincidence begins to feel like an inadequate explanation. The Hindu concept of the yugas, the great ages through which the universe eternally cycles, represents perhaps the most elaborate cosmological timekeeping system any human culture has ever devised. And when you examine its mathematics closely, when you trace the numbers that form its foundation, you encounter something that should give you pause, something that connects directly to the countdown we have been following through the clay tablets of ancient Iraq. Picture yourself now in Varanasi, one of the oldest continuously inhabited cities on Earth, where the Ganges flows past ghats that have witnessed thousands of years of human ritual, where priests still chant verses composed before the pyramids were built, where time itself seems to move differently, layered and cyclical rather than linear and progressive. The Brahmin scholars who preserved the Vedic traditions understood something about time that modern Western consciousness has largely forgotten, that ages have qualities. And that time is not merely a neutral medium through which events pass, but a living force that shapes the very nature of existence. That there are seasons to the cosmos just as there are seasons to the year. According to Hindu cosmology, we exist within a framework of 4 great ages, each one shorter than the last, each one representing a progressive decline in dharma, in cosmic order, in the quality of human life and consciousness. Satya Yuga, the age of truth, comes first, a golden age when humans live for thousands of years, when virtue pervades all existence, when the divine and human worlds remain in intimate contact. This age lasts according to the traditional calculations preserved in texts like the Manusmriti and the Vishnu Purana, for 1,728,000 years. Then comes Treta Yuga, the Silver Age, slightly diminished, virtue beginning to decline, but still predominant, lasting 1,296,000 years. Dwapara Yuga follows, the Bronze Age, where virtue and corruption exist in equal measure, lasting 864,000 years. And finally, Kali Yuga, our current age, the age of darkness and discord, when virtue has declined to 1/4 of its original strength, when human lifespans have shrunk to mere decades, when ignorance and conflict dominate, lasting 432,000 years. These 4 ages together form one Mahayuga, one great cycle, totaling 4,320,000 years, after which the universe dissolves and reforms, and the cycle begins again with a new Satya Yuga, endless repetition through eternity. Now here is where your attention should sharpen, where the pattern we have been tracking through Mesopotamian tablets suddenly appears in an entirely different cultural context. Look at the numbers, not at their mythological framing, but at their mathematical structure. Satya Yuga equals 4 times 432,000. Treta Yuga equals 3 times 432,000. Dwapara Yuga equals 2 times 432,000. Kali Yuga equals 1 times 432,000. The entire system is built on a single base unit, 432,000, and its multiples. The ratio between the ages is exactly 4:3:2:1. This is not mythology fuzzy with poetic license. This is precise mathematical architecture. And that base number, 432,000, is not arbitrary. When you express it in terms of the Sumerian sexagesimal system, 432,000 equals exactly 120 times 3,600, exactly 120 SARs, exactly 120 of those mysterious units that form the backbone of Mesopotamian cosmic calculation. The number appears again when you examine the total reign lengths of the antediluvian kings in the Sumerian king list, where the combined years equal 241,200, which is 67 SARs, which bears mathematical relationships to the same base calculations. The number appears in Babylonian astronomical tablets tracking planetary cycles. It appears in calculations of the precessional Great Year, where 432,000 years equals precisely 16.666 precessional cycles of approximately 25,920 years each. It appears in the mathematics of musical harmonics, where 432 Hz has been proposed as a natural tuning frequency. The same number surfacing independently in systems separated by thousands of miles and developed by cultures with no documented contact. How do we explain this convergence? The conventional scholarly answer is that we are pattern-seeking creatures prone to finding connections where none exist. That the number 432,000 is simply a convenient mathematical quantity that different cultures arrived at through different paths. That the apparent connection is an artifact of our desire to find universal truths rather than evidence of actual cultural transmission or common origin. This explanation may be correct, but consider the alternative. Consider the possibility that both the Sumerian astronomers and the Vedic sages inherited their numerical systems from a common source, from a tradition older than either culture, from knowledge bearers who established the same cosmic countdown in multiple locations, ensuring that even if one tradition was lost, others would preserve the essential calculations. The Hindu texts themselves suggest something like this. They speak of the Saptarishis, the 7 sages who preserve knowledge across the dissolution and recreation of worlds, who carry forward the essential wisdom from one age to the next. They speak of avatars, divine beings who descend to Earth at specific moments in the cosmic cycle, who teach and guide and intervene at the appointed times. They speak of the gods withdrawing from direct involvement in human affairs as the ages progress, becoming more distant, more inaccessible, leaving only their instructions behind. The parallel to the Anunnaki departure narrative is striking. In both traditions, divine beings once walked among humans, then withdrew, leaving behind systems of knowledge, calendars, calculations, priesthoods charged with maintaining the connection until the appointed time of return. And in both traditions, that time of return is tied to cosmic cycles, to astronomical alignments, to the completion of vast calculations that extend far beyond any individual human lifetime. The countdown, if it exists, appears to be global, not limited to one culture or one continent, but encoded in traditions spanning the ancient world, each preserving fragments of a common inheritance, each counting towards something that the original knowledge bearers deemed worthy of such elaborate preservation. Now, let us cross an even greater distance, an ocean that conventional history tells us was uncrossable by ancient peoples, to examine a calendrical system that emerged in complete isolation from Old World influence, a system that nonetheless tracks cosmic cycles with mathematical precision that rivals anything we have found in Mesopotamia or India. The Mayan long count calendar has generated enormous popular interest, particularly around the year 2012, when one of its major cycles completed. But the sensationalism surrounding that date obscured something more profound, something that scholars of comparative chronology have struggled to explain within conventional frameworks. Imagine yourself in the jungles of Guatemala, in the ruins of Tikal or Uaxactun, where stone stelae still stand inscribed with dates reaching back thousands of years before the monuments were erected, where Mayan astronomers tracked cycles so long that they would not complete within hundreds of human generations. The long count, unlike the cyclical calendars used for everyday purposes, was a linear count of days extending from a mythological starting point that corresponds in our calendar to August 11, 3114 for Christus. But this linear count was organized into nested cycles that reveal a sophisticated awareness of long-term astronomical patterns. The basic unit was the kin, 1 day. 20 kin made 1 weinel, roughly a month. 18 weinel made 1 ton, approximately 1 year of 360 days. 20 tun made 1 katun, approximately 20 years. 20 katun made 1 baktun, approximately 394 years. And 13 baktun made 1 great cycle of approximately 5,125 years, which is what completed in December 2012. But the Mayans did not stop there. Above the baktun, they calculated the piktun, the kalabtun, the kinchiltun, the alautun, cycles extending millions and billions of years into the past and future, calculations that no practical purpose could justify, calculations that only make sense if you are tracking something cosmic, as something that unfolds over geological timescales. The 5,125-year Great Cycle, which attracted so much attention, is particularly interesting when examined in relation to precessional astronomy. The precessional cycle, the slow wobble of Earth's axis that causes the spring equinox to shift through the constellations over approximately 25,920 years, can be divided into 12 precessional ages of approximately 2,160 years each, one for each zodiacal constellation. But it can also be divided differently. 5 cycles of 5,184 years would equal 25,920 years, almost exactly. The Mayan Great Cycle of 5,125 years is tantalizingly close to this 5th part of the precessional cycle. Was this coincidence? Were the Mayans independently tracking a precessional subdivision that happened to approximate their calendar cycle? Or were they working from the same astronomical knowledge base as the Old World civilizations, perhaps inherited from a common source, perhaps established by the same beings who set the countdown in Mesopotamia? The conventional answer is independent development. The Mayans were sophisticated astronomers. They tracked the synodic periods of Venus with extraordinary precision. They predicted eclipses centuries in advance. They could have, through their own observations, developed calendrical systems that happened to align with astronomical realities that Old World astronomers also observed. This is possible. But consider the specificity of the parallels. Consider that both Mesopotamian and Mesoamerican astronomers used base 20 and base 60 in their calculations, that both tracked similar planetary cycles, that both developed systems explicitly designed to count toward completion points in the distant future. Consider the Mayan creation myth in the Popol Vuh, which describes multiple previous worlds that were destroyed and recreated, cycles of creation strikingly similar to the Hindu yugas, with the current world being the 4th or 5th depending on interpretation. Consider that Mayan priests, like Sumerian priests, claimed their knowledge descended from divine teachers, beings who came from elsewhere and established the systems of knowledge that humans were charged with preserving. The feathered serpent, Kukulkan to the Maya and Quetzalcoatl to the Aztecs, was described as a civilizing deity who taught astronomy, mathematics, agriculture, and writing, then departed with the promise of return. And the parallel to the Anunnaki and to the Hindu avatars is unmistakable. Divine beings who teach, who establish systems of cosmic tracking, who depart, and whose return is tied to the completion of cycles. If the countdown was established globally, if the same timekeeping system was encoded on multiple continents by beings or by a civilization that predated our recorded history, then the Mesoamerican evidence would be exactly what we would expect to find: a parallel system, using different symbols but tracking the same underlying reality, counting toward the same cosmic appointments, preserving the same essential knowledge against the possibility that other traditions might be lost. Now let us turn to Egypt, to the civilization that has fascinated seekers of ancient mysteries more perhaps than any other. To the monuments that still stand after 5,000 years as testament to a sophistication we are only beginning to appreciate. The conventional chronology places Egyptian civilization as emerging around 3,100 BCE, roughly contemporary with the Sumerian civilization in Mesopotamia, and scholars have long debated whether the two civilizations developed independently or shared some common ancestry or cultural exchange. What concerns us here is the evidence that Egyptian astronomers, like their Mesopotamian and Indian and Mesoamerican counterparts, tracked cosmic cycles far longer than any practical purpose required, and encoded this knowledge in monuments designed to last through ages. The Dendera zodiac, now housed in the Louvre in Paris, is a bas-relief from the ceiling of the Hathor temple at Dendera, depicting the constellations of the zodiac, along with various Egyptian deities and astronomical symbols. Mainstream Egyptologists date the current temple to the Ptolemaic period, around the 1st century BCE, though it was built on the site of much older structures. But the zodiac itself has been the subject of intense debate. Some researchers, examining the positions of the constellations and certain marker stars depicted in the relief, have argued that it records a sky from a much earlier era, perhaps encoding processional knowledge that predates the Ptolemaic reconstruction by thousands of years. The French astronomer Jean-Baptiste Biot, working in the early 19th century, calculated that certain features of the Dendera zodiac corresponded to a sky from approximately 700 BCE. Other researchers have proposed dates stretching back much further, to 4000 BCE or earlier, based on different interpretations of which stars and constellations are being depicted. The debate remains unresolved, but what is not debated is that the zodiac encodes astronomical information, that the Egyptians were tracking precessional positions, that they understood the slow shift of the heavens over millennia and found this knowledge important enough to preserve in stone. The pyramid shafts at Giza provide even more intriguing evidence. The so-called air shafts extending from the King's Chamber and Queen's Chamber of the Great Pyramid were long thought to serve ventilation purposes. But in the 1960s, the astronomer Virginia Trimble and the Egyptologist Alexander Badawi demonstrated that these shafts aligned precisely with specific stars as they would have appeared around 2500 BCE, the conventional date of the pyramid's construction. The southern shaft from the King's Chamber aligned with the belt stars of Orion, associated with the god Osiris. The southern shaft from the Queen's Chamber aligned with Sirius, associated with the goddess Isis. The northern shafts aligned with circumpolar stars associated with immortality and the celestial realm of the gods. But here is what should give us pause. If the builders were merely aligning to the stars of their own era, why the extraordinary precision? The alignments are accurate to within fractions of a degree. This suggests either remarkable engineering skill, which the Egyptians certainly possessed, or that the alignments were of cosmic importance, that the pyramids were designed to connect Earth with specific celestial coordinates, to function as instruments in some larger astronomical system. The concept of Zep Tepi, the first time, adds another layer to this mystery. Egyptian texts refer to an age before the pharaohs, a time when the gods themselves ruled Egypt, when divine beings walked the earth and established the principles of civilization. The Turin King List, a fragmentary papyrus now in the Egyptian Museum in Turin, records not only the historical pharaohs, but also lists of divine and semi-divine rulers who preceded them, reigns stretching back thousands of years before what conventional history recognizes as the beginning of Egyptian civilization. The parallel to the Sumerian king list is striking. Both traditions preserve records of impossibly long reigns by divine or semi-divine beings before a transitional period that brought human kings to power. Both traditions encode this information in the same format, king lists with reign lengths, as if both were working from a common template. Both traditions suggest that the divine beings departed, withdrew from direct involvement, leaving their knowledge and their monuments behind. If the countdown we have been tracking through Mesopotamian tablets was established by beings who operated globally, who traveled not just to Sumer, but to Egypt and India and Mesoamerica, then we would expect to find exactly this pattern: parallel traditions encoding the same cosmic cycles in different cultural frameworks, monuments aligned to the same astronomical realities, king lists preserving the same essential chronology, all counting toward the same appointed time. Let yourself breathe now. We have traveled far tonight, from the museum cases of London to the Ghats of Varanasi, from the jungle pyramids of Guatemala to the sands of Egypt. Different continents, different millennia, different languages and gods and architectural traditions. And yet, the same numbers keep surfacing, the same cycles keep turning, the same pattern of divine beings teaching, establishing, departing and promising return. The same obsessive preservation of cosmic calculations that extend far beyond any practical necessity. You do not need to hold all of this in your conscious mind. The patterns are there whether you actively contemplate them or not. The timer, if it exists, has been running for thousands of years across multiple continents, preserved by scribes and priests who may not have fully understood what they were preserving, copied from generation to generation because the tradition demanded it, because something deep in human consciousness recognized its importance even when the specific meaning had been lost. Let these connections settle like sediment in still water. The question of whether these parallels represent cultural diffusion, independent discovery, or evidence of a common prehistoric source remains open. Scholars debate it. They will continue to debate it. Certainty eludes us, and perhaps certainty should elude us. The mystery is the point. The wonder is the gift. What matters tonight is simply that you have seen the pattern, that you have traced the threads connecting traditions that seemed isolated, that you have glimpsed the possibility of a global countdown encoded in the mathematical foundations of the ancient world. Tomorrow, the questions will wait. The tablets will rest in their cases. The temples will stand under distant skies. The numbers will continue their patient relationships, 432,000 to 3,600 to 25,000, 920 to 2,160,000, interlocking like gears in a cosmic clock that someone, somewhere, set running long before history began. For now, let the pattern hold you without demanding understanding. Let the convergence of ancient traditions become a kind of music, mathematics singing across millennia, cultures harmonizing without knowing they shared a common score. Rest in the not knowing, float in the mystery. The timer continues whether we understand it or not. With sleep approaches, and with it, perhaps, dreams of connections we can sense but not prove, of knowledge preserved against disasters we can barely imagine, of cycles completing and beginning again in the endless breathing of cosmic time. Appointed time. So what does the timer count toward? What happens when the calculations complete? When the celestial alignments the ancient astronomers tracked so obsessively finally arrive at whatever destination point they were measuring toward? This is the question that haunts every serious investigation of Mesopotamian astronomical knowledge, the question the tablets themselves seem to pose but never quite answer. And tonight, as you drift between waking and sleep, we will explore three possible interpretations, three ways of understanding what the Anunnaki countdown might mean. Each one stranger than the last, each one carrying implications that reach directly into our present moment, into the years we are living through right now. The first interpretation is the most literal and perhaps the most unsettling, the return hypothesis. the proposition that the timer marks an actual physical return, that the Anunnaki departed Earth with every intention of coming back, and that the elaborate astronomical calculations preserved on clay tablets across millennia were designed to track exactly when that return would occur. Consider the textual evidence, and there is considerable textual evidence. If we read the sources carefully, the Mesopotamian texts do not describe the gods as permanently absent. They describe them as departed, withdrawn, gone away to a place from which they might return. The Era epic, that haunting Babylonian composition from the first millennium BCE, describes a time when Marduk, the chief god of Babylon, left his city and chaos ensued in his absence. But the text also preserves the promise that he would return, that his abandonment was temporary, not permanent, that the suffering of the present age would eventually end when divine order was restored. Similar themes appear throughout Mesopotamian literature. The gods are away, the gods have risen to heaven, the gods have crossed to the other side, but they remain connected to Earth through temples and rituals and astronomical observations, and someday the crossing will reverse. The rising will become a descent, the departure will become an arrival. The concept of Nibiru plays into this interpretation. Though we must be careful here, because Nibiru means different things in different contexts. In the astronomical tablets, Nibiru sometimes refers to Jupiter, sometimes to a point of celestial crossing where planetary paths intersect, sometimes to something less easily identified. Zechariah Sitchin, whose translations remain controversial among professional Assyriologists, interpreted Nibiru as a 12th planet on a highly elliptical orbit that brings it through the inner solar system every 3,600 years, 1 SAR in Sumerian mathematics. And according to Sitchin, the Anunnaki came from this planet, their comings and goings dictated not by choice, but by orbital mechanics. When Nibiru swung close to Earth, they could travel between worlds. When it retreated to the outer solar system, they were trapped on whichever world they occupied. And the elaborate astronomical calculations were necessary to track exactly when the next close approach would occur, when the window of travel would open again. Now, mainstream scholarship rejects most of Sitchin's specific claims. His translations have been disputed, his astronomical propositions contradicted by modern sky surveys that have found no evidence of a large planet on the required orbit. His interpretive leaps from cuneiform tablets to extraterrestrial visitation questioned at every step. And yet, certain puzzles remain that conventional explanations struggle to fully address. The precision of Mesopotamian astronomical calculations is remarkable. These were not primitive guesses, but accurate measurements that modern computers can verify. Predictions of planetary positions and eclipse times that prove correct across spans of centuries. Where did this knowledge come from? Who needed such precision? Why invest the enormous scribal resources required to maintain and transmit these calculations across generations if they served only calendar keeping or omen reading? The counter-argument is that humans are capable of patient observation across generations, that sophisticated astronomical knowledge can develop naturally in cultures with clear skies, stable institutions, and strong traditions of record-keeping, that we need not invoke extraterrestrial sources for what human intelligence could achieve, given sufficient time and motivation. This counter-argument is probably correct, but it does not fully explain why the calculations extend so far beyond practical necessity, why the Mesopotamian astronomers tracked cycles spanning tens of thousands of years, when they themselves would witness only tiny fragments of those cycles. Why they seemed to be keeping time for someone else, someone with a longer perspective, someone who might actually need to know when certain celestial configurations would recur across spans vastly exceeding human lifespans. If the return hypothesis is true, if the timer really does mark a literal return, what might that look like? What should we expect if the Anunnaki, or beings answering to that name, were to appear in our skies tomorrow? This ventures deep into speculation, into territory where evidence offers no guidance and imagination must serve instead. Perhaps ships descending through clouds, perhaps signals from the outer solar system announcing approach. Then perhaps something so strange our current categories cannot contain it. Perhaps something so subtle most people would not recognize it as contact at all. We cannot know. We can only acknowledge the possibility and set it alongside the alternative interpretations. The second interpretation is darker, more immediate, more closely tied to physical evidence in the geological and archaeological record. This is the catastrophe hypothesis, the proposition that the timer does not mark a return but a recurrence, not the arrival of beings, but the arrival of destruction, a catastrophic cycle that the Anunnaki, whoever they were, understood and encoded in their astronomical calculations as a warning to future generations. Consider the evidence for catastrophic cycles in Earth history. Not mythological evidence, but geological, archaeological. The climatological evidence preserved in ice cores and sediment layers, and the sudden disappearances of cultures from the record. Around 12,800 years ago, at the boundary between the Pleistocene and the Holocene, something catastrophic occurred. Ice cores from Greenland show a sudden temperature plunge, a return to near glacial conditions that lasted over 1,000 years. The period called the Younger Dryas after the Arctic wildflower, whose pollen suddenly reappears in sediments marking cold conditions. The megafauna that had survived the Ice Age for hundreds of thousands of years, the woolly mammoths and mastodons and saber-toothed cats and giant ground sloths, went extinct abruptly, not gradually declining, but suddenly vanishing from the record. The Clovis culture in North America, the dominant Paleo-Indian technology, disappeared at precisely this boundary, their distinctive spear points no longer appearing in sites above the Younger Dryas layer. What happened? The conventional explanation involves meltwater pulses disrupting ocean circulation, triggering rapid climate change that destabilized ecosystems already stressed by the transition from glacial to interglacial conditions. But some researchers, notably the team behind the Younger Dryas impact hypothesis, argue for something more dramatic, evidence of cosmic impact. Not a single massive asteroid strike like the one that killed the dinosaurs, but perhaps multiple airbursts from a disintegrating comet, distributing destruction across the northern hemisphere, igniting continent-spanning wildfires, flash-melting portions of the ice sheets, releasing floods of meltwater that reshaped coastlines within human lifetimes. The evidence for this hypothesis remains contested. Some studies find the expected impact proxies, shocked quartz and nanodiamonds and platinum spikes, while others fail to replicate these findings or offer alternative explanations for the anomalies. The scientific debate continues. But for our purposes, what matters is the pattern, a catastrophic event approximately 12,800 years ago that corresponds remarkably well with half the precessional cycle, half of 25,920 years, half of the great cosmic clock that the Mesopotamian astronomers tracked so carefully. And if we look for similar events at similar intervals, we find them not with perfect regularity. Catastrophes are not clockwork, but with rough periodicity that suggests some underlying cycle. Is around 4,200 years ago, the so-called 4.2 kilo-year event, a period of severe drought that corresponds with the collapse of the Akkadian Empire in Mesopotamia, the end of the Old Kingdom in Egypt, the abandonment of major urban centers across the Indus Valley. Around 3,200 years ago, the Bronze Age collapse, when almost every major civilization in the Eastern Mediterranean simultaneously fell. The Mycenaeans, the Hittites, the Egyptians weakened to a shadow of their former power. Trade networks shattered, writing systems forgotten, population declined dramatically. The specific causes varied: drought in some regions, earthquakes in others, the mysterious sea peoples attacking coastal cities, but the simultaneity suggests some larger disruption, with some systemic stress that pushed multiple civilizations past their breaking points at roughly the same time. If there is a catastrophic cycle, roughly 10,000 to 12,000 years between major events, we may be approaching another transition point. The Younger Dryas occurred approximately 12,800 years ago. We are now approximately 11,700 years into the Holocene, the stable warm period that allowed human civilization to flourish. If the cycle holds, if catastrophic conditions recur at roughly the precessional half period, the next transition may be centuries away, or it may be imminent. The uncertainty in the calculations spans enough time to make precise prediction impossible. This interpretation casts the Anunnaki timer in a different light, not as a countdown to return, but as a countdown to catastrophe. Not a promise, but a warning. If the beings who established these calculations understood the cyclical nature of Earth catastrophes, understood that every 12,000 years or so conditions would shift dramatically enough to threaten civilization, they might have encoded that knowledge in astronomical form. Specifically because astronomical constants do not change, because precessional cycles would remain measurable by any culture with sufficient astronomical sophistication, because the warning would remain legible even if the specific language and culture that created it disappeared. The message would not be, "We will return." The message would be, "Prepare, survive, rebuild. The cycle continues, and you must be ready." This interpretation has the advantage of not requiring extraterrestrial visitation or literal divine beings. The Anunnaki might have been an advanced human civilization that existed before the Younger Dryas, a culture that developed sufficient astronomical knowledge to recognize catastrophic cycles and sought to preserve that knowledge for whoever survived the coming destruction. Their gods would be cultural memory of those antediluvian scientists, their myths distorted records of actual events, their astronomical calculations a coded warning that we are only now beginning to decode. The third interpretation is perhaps the strangest, requiring no physical events at all, neither return nor catastrophe, but positing that the timer tracks something more subtle, something internal to human consciousness itself. The consciousness hypothesis suggests that the Anunnaki understood precessional ages not merely as astronomical curiosities, but as psychological epochs, periods when human consciousness itself, shifts in response to celestial influences we do not yet understand. Consider the precessional ages as they correspond to human cultural development. And while correlation does not prove causation, the patterns are striking enough to warrant contemplation. The age of Gemini, roughly 6,000 to 4,000 BCE, corresponds with the development of early writing systems, the emergence of trade networks connecting distant communities, the first systematic recording of knowledge. Gemini, the twins representing duality, communication, the bridging of separate entities through shared symbols. The age of Taurus, roughly 4,000 to 2,000 BCE, it corresponds with the height of agricultural civilization, the building of permanent monuments, the worship of bull imagery across cultures from Sumer to Egypt to Crete. Taurus representing stability, fertility, the patient work of cultivation, the bull as sacred symbol appearing in religious iconography worldwide. The age of Aries, roughly 2000 BCE to the year 0, corresponds with the rise of imperial conquest, the age of warrior kings and expanding empires, the shift from bull sacrifice to ram sacrifice in religious practice, Moses with his ram's horn trumpet, the golden calf condemned as relic of an older age, Aries representing aggression, initiative, the martial energy that built Rome and Persia and Alexander's brief, bright empire. The age of Pisces, roughly the year 0 to now, corresponds with the rise of Christianity and Islam, religions of faith and sacrifice, the fish as early Christian symbol, the emphasis on belief over knowledge, martyrdom as spiritual achievement, the dissolution of individual will into divine providence, Pisces representing sacrifice, transcendence, the spiritual depths that lie beneath material surface. And now, according to precessional calculation, we are entering or have recently entered the age of Aquarius, the water-bearer pouring forth knowledge upon humanity. Aquarius representing technology, collectivity, the dissolution of boundaries between nations and individuals and species, the age of information and artificial intelligence and global consciousness connected through electronic networks. If the precessional ages really do correlate with shifts in human psychological orientation, and this remains a massive if, and then the Anunnaki timer might track not external events, but internal transformations, the points at which human consciousness evolves or devolves, expands or contracts, achieves new capacities or loses old ones. The timer would not mark the return of beings from the sky or catastrophe falling from heaven. It would mark threshold moments in human development, evolutionary leaps or declines, the birth of new forms of awareness or the death of old ones. This interpretation suggests that the Anunnaki, whoever they were, understood something about the relationship between consciousness and cosmos that modern materialist science has not yet grasped. The idea that mind and matter are not separate substances but aspects of a single reality, that celestial configurations somehow influence the forms consciousness can take, that the great precessional wheel grinding through its 26,000-year cycle carries human awareness through transformations as predictable and as dramatic as the seasons of a single year. This might sound mystical, and perhaps it is. But we should note that mainstream psychology has barely begun to explore the question of how consciousness relates to cosmic context. We know that human mood and behavior correlate with circadian rhythms, with seasonal changes, with lunar cycles, however subtly. We know that the brain is an electrochemical organ influenced by environmental electromagnetic fields. We do not know the limits of such influences. The consciousness hypothesis does not require supernatural causation, only that the cosmos influences mind in ways we have not yet mapped, and that the Anunnaki somehow understood these influences and encoded their knowledge in astronomical form. That the timer tracks not their return or coming disaster, but our own transformation. The moment when humanity becomes something different, passes through a door we cannot yet see, achieves or fails some test, the original calculation makers deemed significant enough to mark across millennia. So, where does this leave us? 3 hypotheses, and no way to determine which, if any, is correct. The return, the catastrophe, the consciousness shift, each supported by some evidence and contradicted by other evidence, each requiring leaps of interpretation that skeptical minds will refuse to make. Perhaps none of them are correct. Perhaps the astronomical calculations were exactly what mainstream scholarship says they were, on practical tools for tracking celestial events, divorced from any deeper meaning, preserved because scribal cultures preserve texts automatically without requiring that each generation understand the original purpose. Perhaps the Anunnaki were simply mythological constructs, products of human imagination, processing the mystery of origins, bearing no relationship to actual beings or events. Perhaps the timer is our projection, our pattern-seeking minds, finding countdown where there is only calculation, finding meaning where there is only mathematics. And yet the tablets remain, the numbers balance. The processional ages continue their stately rotation through the heavens, carrying us towards some configuration the ancient astronomers deemed worthy of obsessive documentation. Whatever interpretation we favor, whatever we believe or refuse to believe, the calculations themselves are real, the patterns cross-cultural, the questions unanswered after a century of modern scholarship. Something in the human past seemed to think these measurements mattered tremendously. Something invested enormous resources in preserving them across the collapse of empires and the death of languages. Something wanted future generations to know exactly where we stood in the great cosmic cycle. And now, in this moment, as you drift towards sleep in a year that the ancient astronomers might have marked on their impossibly long calendars, the countdown continues. If countdown it is, the timer runs, if timer it was ever meant to be. The appointed time approaches, or has passed, or is perpetually approaching, forever, just over the horizon of what we can verify. Let these possibilities float beside you as sleep approaches. The return, the catastrophe, the consciousness shift. 3 stories about what the future holds. 3 ways of interpreting calculations made by scribes who lived and died and turned to dust while their clay tablets endured. You do not need to choose between them tonight. You do not need to believe any of them. You need only acknowledge that the questions exist, that the ancient world left us puzzles we have not solved, that somewhere in museum basements the tablets wait with their endless columns of numbers, patient as they have been patient for 4,000 years, waiting for someone to finally understand what they were trying so desperately to preserve. Deep time. Let us return now to where we began, to the quiet gallery in the British Museum where the MUL.APIN tablets rest in their climate-controlled case. Those unassuming rectangles of baked clay covered in wedge-shaped impressions that most visitors walk past without a second glance. And let us consider what the scribes who created them thought they were doing when they pressed their styluses into wet clay some 3,000 years ago, copying calculations that were already ancient in their time, preserving astronomical tables that extended far beyond any practical purpose they could have needed, tracking cycles that would not complete for thousands of years after their own civilizations had crumbled to dust. Did they understand what they were preserving? Did they know they were maintaining a countdown? Or were they like monks in medieval monasteries, copying Latin texts they could not fully read, preserving knowledge out of reverence and duty rather than comprehension, trusting that the act of preservation itself was sacred even if the meaning had been lost generations before? The chain of transmission stretches back into shadows we cannot fully illuminate, each link carrying forward what the previous link passed to it, each generation of scribes copying what their teachers copied, maintaining the numbers with obsessive precision, even as the original context slowly eroded like writing on a stone left too long in the rain. Sumerian knowledge passed to Akkadian scholars who translated what they could and preserved what they could not translate. Akkadian knowledge passed to Babylonian astronomers who refined the calculations and added their own observations. Babylonian knowledge passed to Persian magi who incorporated it into their own cosmic frameworks. Persian knowledge passed to Greek philosophers who systematized it and gave it new names. Greek knowledge passed to Arabic scholars who preserved it through the European Dark Ages, translating, commenting, sometimes correcting, always copying. Arabic knowledge passed to medieval European universities, where it merged with fragments preserved through other channels, monastic libraries, Byzantine scholars, traders who carried ideas along with spices and silk. And from medieval Europe, it passed to us. Through the scientific revolution, through the development of archaeology, through the patient work of linguists who learned to read cuneiform again after millennia of silence, through the excavations that brought the tablets up from the desert sands and shipped them to museums in London and Paris and Berlin and Baghdad. At each transition, something was lost. Languages died and had to be reconstructed. Contexts evaporated as the cultures that created them collapsed. The living tradition of astronomical observation that gave the numbers meaning became instead a textual tradition of copying numbers whose significance was no longer fully understood. The priests who knew why these cycles mattered died without passing that knowledge forward, or passed it to students who remembered the how but forgot the why. And yet, the numbers themselves survived. The calculations remained accurate. The astronomical tables could still be verified against the actual movements of planets and stars. Whatever meaning the original creators invested in these cycles, the mathematical structure remained intact, waiting for someone to recognize its significance, to ask the questions we have been asking tonight. We can read the tablets now. Modern Assyriologists can translate cuneiform with reasonable confidence. Modern astronomers can verify that the planetary periods recorded in MUL.APIN are accurate to within the limits of naked eye observation. Modern mathematicians can recognize the sophistication of the sexagesimal calculations, the elegance of the base 60 system for tracking celestial cycles. We can reconstruct what the tablets say, but can we reconstruct what they mean? We may be like children who inherit a grandfather clock from ancestors we never met. A beautiful mechanism of gears and weights and pendulums, still running after generations, still keeping perfect time, still chiming at regular intervals. We can admire the craftsmanship. We can appreciate the precision. We can read the hours and minutes on the face. But we have forgotten what appointment the clock was set to mark. Was there an appointment at all? Or did our ancestors simply love the beauty of clockwork, the elegance of measuring time for its own sake? We cannot ask them. They are long gone. Only the clock remains, ticking, ticking, counting towards something or nothing we cannot know. This is our position with the Sumerian astronomical tablets. The mechanism still runs. The calculations still work. But the purpose? If there was a purpose beyond practical astronomy, that may have been lost so long ago that even the scribes who copied the tablets 3,000 years ago no longer remembered it. They preserved because preservation was their duty. We study because study is our nature. And the countdown, if it is a countdown, continues whether we understand it or not. What does it mean to live in countdown time? What does it mean to walk through your days with the awareness, however faint, however uncertain, that ancient cultures may have been tracking cycles that have not yet completed, that the timer they set may still be running, that the appointed moment they marked in their astronomical tables may lie in our future rather than in the distant past? Perhaps it means nothing at all. Perhaps the countdown is an illusion, a pattern we project onto astronomical calculations that served entirely practical purposes, agricultural calendars, ritual schedules, the prediction of eclipses that terrified ancient populations. Perhaps the Sumerians and Babylonians and Egyptians and Mayans all tracked long cycles simply because they were sophisticated enough to recognize that such cycles existed, not because anyone told them to, not because they were preserving instructions from departed gods, but because human minds are pattern-seeking and the cosmos is full of patterns to seek. This possibility is real. This possibility may be the truth. Mainstream scholarship largely accepts this interpretation, and mainstream scholarship has a better track record than fringe theories, a more rigorous methodology, a healthier skepticism toward extraordinary claims. We should hold our speculations lightly, should acknowledge that the timer may not exist at all. But perhaps it means something else. Perhaps we are approaching a significant transition, and the ancient astronomers knew it, tracked it, tried to warn us about it in the only language they possessed, the language of mathematics and mythology and monuments built to last. Perhaps the processional shift into Aquarius, happening now within our lifetimes, marks a genuine threshold, a point of transformation that will be obvious only in retrospect, the way historical turning points always are. Perhaps the catastrophic cycles the ancients seem to have tracked, the roughly 12,000-year rhythm that some researchers propose, is real, and we are approaching another node in that cycle. Another moment when the stability we take for granted will be tested. Or perhaps the countdown marks something more subtle, not physical catastrophe, but psychological transformation, a shift in human consciousness that the ancient cultures understood better than we do, a maturation of the species that certain celestial configurations somehow facilitate or symbolize. These are possibilities we cannot confirm or deny. They are hypotheses without controlled experiments, speculations without falsifiable predictions. They exist in the realm of wonder rather than knowledge, faith rather than science. And yet there is value in the awareness itself, regardless of whether the timer is real. The Sumerian consciousness of deep time, of cycles extending far beyond individual lifespans, of continuity across generations and even across civilizations. This consciousness is worth recovering, even if we strip away all the fringe theories and alternative histories and ancient astronaut speculations. Our modern culture is catastrophically short-sighted. We think in quarterly earnings reports and election cycles, and 5-year plans that rarely survive contact with reality. We discount the future at rates that make our grandchildren worthless in our economic calculations. We make decisions with 10-year horizons when the consequences will unfold over centuries. We are not good at deep time. We do not naturally think about what the world will be like in 1,000 years, or what our actions today might mean for the 7th generation forward, or what responsibility we bear to those who will inherit the consequences of our choices long after we are dust. But the ancient cultures we have been exploring tonight thought differently. They built monuments designed to last millennia. They copied astronomical tablets preserving calculations that would not mature for thousands of years. They thought of themselves as links in chains that stretched back to the first humans and forward to humans not yet born. They were not trapped in the eternal present the way we often seem to be. This awareness, this deep time consciousness, is worth cultivating regardless of whether there is literally a countdown running, regardless of whether the Anunnaki were real or mythological or something we cannot yet categorize. To think in deep time is to recover a portion of human heritage that we have largely abandoned. It is to recognize that we are not the first and will not be the last. It is to take seriously our responsibilities to those who come after, to ask not just what benefits us now, but what we are passing forward. The Sumerians passed forward their astronomical calculations, their mathematical systems, their stories and their questions. We will pass forward something too. The question is what? The question is whether we will think carefully about our legacy or simply let it accumulate haphazardly, whether we will be good ancestors or merely ancestors, whether the future will look back at us with gratitude or with grief. How do we live with mystery without anxiety? How do we hold the possibility that something significant is unfolding, that we may be approaching a transition point ancient cultures marked, and we have forgotten without collapsing into fear or fanaticism? The answer, I think, is in the quality of attention we bring. Not grasping attention that needs to resolve every uncertainty, that cannot rest until all questions are answered, that treats mystery as a problem to be solved rather than a space to be inhabited, but open attention that can hold questions without demanding answers, that can float in not knowing without drowning, that finds the uncertainty itself beautiful and generative rather than threatening. The Sumerians lived for thousands of years with their astronomical calculations, their cosmic frameworks, their awareness of cycles beyond their comprehension. They did not seem paralyzed by the mystery. They built their cities, farmed their fields, raised their children, wrote their poetry, lived their lives within the larger context of cyclical time without that context crushing them. They held the countdown, if that is what it was, as background rather than obsession, as frame rather than focus. We can do the same. We can acknowledge the possibility that something ancient and significant is still unfolding without making it the center of our lives, without reorganizing everything around speculation and prophecy. We can let the questions live in us without being consumed by them. We can be curious without being anxious, open without being obsessed, aware without being afraid. This is perhaps the deepest wisdom the ancient cultures offer us, not any specific prediction or countdown or prophecy, but the capacity to live with deep time, to hold vast scales in consciousness without being crushed by them, to find meaning and purpose in our brief moment, while acknowledging that our moment is part of something immeasurably larger. We began tonight with a clay tablet in a museum. We have traveled through millennia and across continents. We have examined astronomical calculations of remarkable precision, mythological narratives of divine departure and promised return, mathematical constants that echo across cultures with no obvious connection, catastrophic cycles that may or may not correlate with ancient predictions. We have speculated freely, entertained possibilities that mainstream scholarship rejects, opened doors that cautious historians keep firmly closed. And we have arrived, as we must arrive, at a question without an answer. Did the Anunnaki, whoever or whatever they were, set a timer before they left Earth? And if so, what does it count toward? We do not know. The evidence is suggestive but not conclusive. The patterns are fascinating but not proof. The convergences across cultures are striking, but could be coincidence or cultural diffusion, or the natural tendency of human minds to find patterns even where none exist. The astronomical calculations are precise, but precision alone does not reveal purpose. The monuments are aligned, but alignment could serve ritual functions without encoding any countdown. The numbers recur, but recurring numbers might simply reflect the mathematical properties of the cosmos rather than any deliberate message. We are left where all serious investigation of ancient mysteries leaves us, with more questions than answers, with wonder rather than certainty, with possibilities rather than conclusions. The tablets will not tell us more than they have told us. The monuments will not speak more clearly than they have spoken. The calculations will not suddenly reveal their purpose after millennia of silence. If there is a timer, it remains inscrutable. If there is an appointed moment, it remains unmarked on any calendar we possess. And perhaps this is exactly where we should be, especially at this hour, especially as sleep approaches, especially as the conscious mind loosens its grip and allows the deeper currents of psyche to rise. Not clutching at answers, but floating in questions. Not needing to know, but willing to wonder. Not anxious about uncertainty, but at peace with the limits of human understanding. The tablets are still in their cases. The fluorescent lights in the museum have dimmed for the night. Security guards walk their rounds past display cases full of mysteries no one fully comprehends. And somewhere in those cases, pressed into clay 4,000 years ago, calculations continue that we can read but not fully understand. Numbers that add up correctly to totals whose significance escapes us. Astronomical tables tracking cycles that have not yet completed. A timer perhaps still running toward an appointment no living human remembers being set. Or perhaps not. Perhaps there is no timer. Perhaps the ancient astronomers were simply doing astronomy, simply tracking the heavens because the heavens were trackable, simply calculating cycles because cycles existed to be calculated. Or perhaps we are the ones who invested their work with significance it was never meant to carry, who saw countdown clocks in what were merely calendars, who projected our own eschatological anxieties onto the innocent arithmetic of ancient stargazers. Both possibilities remain open. Both will likely remain open forever. The evidence will not resolve into certainty, no matter how long we study it, no matter how many tablets we translate, no matter how many monuments we survey. Some mysteries are not meant to be solved. They are meant to be lived with, to be held, to be allowed to work on us in ways we cannot control or fully understand. You can set down these ideas now. Let them drift like boats on still water, present but not requiring attention. The questions do not need to be answered tonight. They do not need to be answered ever. They can simply exist, part of the texture of human wondering, part of the heritage of questions we pass forward to those who come after. If you believe none of what we have explored tonight, that is fine. Skepticism is a healthy response to extraordinary claims. If you believe all of it, that is fine too, though perhaps hold your belief lightly, remembering that certainty is rarely warranted in these matters. If you find yourself somewhere in between, curious but unconvinced, open but cautious, willing to wonder but unwilling to commit, that is perhaps the best place of all, the place where genuine inquiry lives, where questions remain questions rather than hardening into answers that close off further thought. The Sumerians did not ask you to believe. They asked only that you remember. Remember that there was a before, civilizations and ages, and perhaps worlds before the one you know. Remember that there may be an after, transitions and transformations, and perhaps endings that you cannot foresee. Remember that time is deeper than you usually imagine, that the moment you inhabit is one moment in a vast sequence of moments stretching back to the beginning and forward to some end you cannot see. Remember that you are part of something larger than yourself, than your culture, than your species perhaps. And if there is a countdown running, if somewhere in the equations of ancient astronomers a timer still ticks toward an appointment we have forgotten, then remember that too. Not with fear, but with wonder. Not with anxiety, but with openness. Not with the need to know, but with the willingness to be part of a story whose ending you will not live to see. Sleep now. Let the conscious mind release its grip on these questions and allow them to sink into deeper waters. Dream of clay tablets and star charts, of ziggurats rising against desert skies, of scribes pressing styluses into wet clay by lamplight, preserving calculations they did not fully understand for readers they would never meet, trusting that the act of preservation was sacred even when the meaning had been lost. Dream of the chain of transmission, link by link across millennia, knowledge passing from hand to hand, mouth to ear, tablet to tablet, each generation receiving and passing forward, sometimes adding, sometimes losing, but always continuing, always keeping something alive that might otherwise have been forgotten. Dream of the timer if it exists, ticking quietly in the background of all human history, tracking cycles we have forgotten how to read, counting towards something we have forgotten how to name. And if no timer exists, dream instead of the human need to imagine timers, to see patterns, to believe that our moment matters in some cosmic scheme, that we are not merely accidents, but participants in something structured and meaningful and ultimately benevolent. Both dreams are worth having. Both reflect something true about the human condition, our longing for significance, our search for pattern, our hope that the universe cares what happens to us. The timer continues or does not continue. The countdown runs or has never run. The appointed moment approaches or exists only in our projections. We cannot know. And not knowing, we rest. The stars wheel overhead as they have wheeled for billions of years, indifferent to our questions, are beautiful in their indifference. The clay tablets wait in their cases, patient as only ancient things can be patient, holding their secrets or holding only the records of careful observation without deeper purpose. And you, descendant of all who came before, ancestor of all who will come after, link in a chain that stretches back to the first human who looked up at stars and wondered. You rest now. Tomorrow the questions will still be there. Tomorrow the tablets will still wait. Tomorrow the timer, if it runs, will still run. Tonight, let it all go. Let the ancient world recede like a tide going out, leaving shells and strange treasures on the beach of your consciousness to be examined in the light of morning. Let the speculations settle, the theories quiet, the possibilities rest. You have traveled far tonight, through time and space and imagination. You have earned your sleep. The Sumerians watched the same stars you might see if you looked out your window now. They wondered as you wonder. They questioned as you question. They lived their lives not knowing how the story would end, just as you live yours. And then they slept as you will sleep, trusting that the morning would come, that the cycles would continue, that whatever the timer marked would unfold in its own time without requiring their vigilance through the night. Trust as they trusted, rest as they rested. The cosmos will continue its turnings without your attention. The countdown will proceed or not proceed, regardless of your waking. You are part of the pattern, but you do not have to hold the pattern together. It held together before you were born. It will hold together after you are gone. Your part is simply to be, to wonder, to rest, to pass forward what you have received, to trust that the chain continues. Good night, fellow traveler through deep time. Good night, inheritor of ancient questions. Good night, link in the chain that stretches from the first counting of stars to the last. May your dreams be peaceful. May your sleep be deep. May you wake refreshed to continue the wandering that makes us human. The timer continues, the stars turn, and you rest. Good night.